In this video, we will more formally examine the idea of slope. The slope of a line is its steepness. Positive slopes go uphill from left to right. Negative slopes go downhill from left to right. We've already looked at slope as the rise over the run. Here's a slope equation that gives the slope of the line given 2 points. I'll show how to use that equation in a bit. Find the slope of the line that connects these 2 points. Point 1 is 1, 6, and point 2 is -1, -2. I'm going to teach you 2 ways to do this that will connect together, but you can decide which way you would like to do this problem. One way is to just do it visually. Graph both of those points, draw the line, and see what the slope is. So the first point is 1, 6. X is 1, y is 6, right here. The second point is x is -1, y is -2, right there. So my line will connect those 2 points. Now, how do I find the slope between these 2 points? Well, remember, slope is the rise over the run. So on your graph, between your 2 points, draw in a box and count. How much did you go up? How much did you go right? 1, 2, 3, 4, 5, 6, 7, 8. I went up 8, 1, 2, right 2. The rise was 8, the run was 2. Double check on this. Am I going uphill or downhill? Well, from left to right, I'm going uphill. So it's going to be a positive number. So 8 divided by 2 is 4. The slope, or the m number, is equal to 4. Now I'll show you with the formula. The formula essentially does the same thing. I'm going to write down my formula first. I always like to write down formulas. It helps me so that I don't miss a piece. Okay, now here are your 2 points. Label the x-coordinate of the first point as x1, the y-coordinate of the first point as y1. Name the x-coordinate of the second point x2, and the y-coordinate of the second point is y2. Now just sub those in. y2 is -2. Minus y1 is 6, x2 is -1, minus x1 is 1. -2 minus 6 is -8. -1 minus 1 is -2. -8 divided by -2 is a +4. So 4 is your m number. Again, what this is doing, it's taking the coordinates, your y coordinates, and subtracting them to find this distance. And it's taking your x coordinates and subtracting them to find this distance. So it's basically doing the same thing that we did visually. You can take your pick whichever way you want to do this. Some people like formulas, some people don't, then do it visually. Number 2, find the slope of the line that connects these 2 points. To do this problem visually, I'll just graph my 2 points. X is -2, y is -1. There's point 1. X is 4, y is -4. There's point 2. My line's not perfect there. Close enough. Okay, so what happens between these 2 points? What would my rise over my run be? Between these 2 points, I'm going to go down 1, 2, 3, down 3, 1, 2, 3, 4, 5, 6, right 6. Down 3, right 6. Now look at your line. It has a negative slope. It's going downhill. So the slope is negative. I always double check that. Sometimes I don't know on these. Am I going up, going down? So just double check at the end that the slope of your line is negative if the line's going downhill, and positive if it's going uphill. My slope is negative 1/2. That's one nice thing about the formula, is it automatically puts the negatives in there for you. So let's use the formula. You can go to your points and put the numbers in there. That helps me to make sure I get the stuff in the right spot. x1, y1 are the x and y coordinates for point 1, and x2, y2 are the x and y coordinates for point 2. Be careful of the negatives. I'll show you what I mean here. Okay, y2, that's negative 4. Now I have a minus sign from my formula, and then y1 is also negative. So do you see how I have the minus sign from the formula and then the negative that went with the negative 1? I have two negatives there. x2 is 4 minus negative 2. Again, a minus sign from the formula and a minus sign from the negative 2 that I'm subbing in. If you remember back from Module 1, when you subtract a negative, it's the same as adding. So this is actually the same as negative 4 plus 1 over 4 plus 2. Negative 4 plus 1 is negative 3. Think money. 4 plus 2 is 6. So I get negative 3, 6, which reduces to negative 1/2. So either way, we get a slope of negative 1/2. Let's talk about slope in an application problem. Mark has $50 in his savings account. He automatically deposits $6 a week from his paycheck into his savings. Write an equation for the amount in the savings account. Use y for the amount and x for the number of weeks. When I make these equations, I usually use, I would use not y and x. I would say like the amount is equal to $6 times the number of weeks plus the $50 that he originally put in. So using their way here, y equals 6x plus 50, where y is the amount and x is the number of weeks. So what's our slope? Our slope is always going to be, again, the m number, the 6. It always matches up with the rate, $6 a week. You're used to doing problems like this. How much will he have in 8 weeks? Well, the 8 is the week. So you'll do 6. You'll sub in 8 for the weeks. 48 plus 50 is 98. And get an amount of 98. Or answering a question like this. When will he have, after how many weeks will he have $122? We just put the $122 in for the amount. And solve for W. So that's how problems would look. Let's look at a couple problems from last test. 49 and 50. I don't know if the numbers match up, but the problems I think were there. Again, what will the slope be? The slope is going to be the $2 a minute, the rate. Number 50, what would the slope be? The $33 per hour, the rate, right? Our equation in this case would be, let's see, the cost of the call would be $2 times the number of minutes plus the flat rate of $15. And then to solve the problem as it's asked from the test, you would sub the 37 in for the cost and then solve for the number of minutes. But the 2 is your slope, your rate. again, this problem, let's see, the cost to paint the house would be $33 times the number of hours plus the flat fee for materials of $125. So again, to solve the problem how it's written, you would put $13.46 in for the cost and then solve for the number of hours. But what I want to talk about is just what's the slope of this line and what does it mean? And it's right there and right there. It's the rate. Slope and rate match up. To find the slope from an equation, you just look for the m number. It's the coefficient of the x term. So it'd be negative 10 in this case. 0.329. I want to add an example here. Sometimes you'll have it where the n number and b number are kind of switched around, and that's okay. It's still the number that's attached to the x. It's always the coefficient of that x term, even if your terms are in a little bit different order than you're used to seeing. Okay, let's look at this third problem here. How are we going to find the slope? Well, you need to get it into slope-intercept form in order to find the slope. So I will want to get y by itself, just like we were doing when we were graphing these. Divide each term by negative 3 to get y by itself. A negative divided by a negative is a positive. Positive divided by a negative is a negative. I'm just going to put minus 4. So what's my slope? 2/3. Because that's the m number. Now let's look at getting a slope from a graph. We've talked a little bit about this at the beginning of this video. But if you have a line like this, let's see, what do I know about my slope? Well, it's going to be negative because it's going downhill. It's going to be a number greater than 1 because I have a line that's greater than a 45-degree angle. So let's see, what I try to look for is where it crosses grid crossings, like right here and maybe right here. And then I put in a slope box. And then I say, okay, how much did it go down? 1, 2, 3. So it went down 3, right 2. So my rise over my run, my rise was negative 3. My run was 2. Again, it's sometimes hard to get the negatives right on this. So just make sure that you double check. Is my line going downhill? Yep, so it's got to be a negative slope, negative 3/2. And again, it's legal to have negative 3/2 or 3 over negative 2, or just make the whole fraction negative out front. Those are all three the same thing. So any way of writing that would be legal. What is the slope of this line? Draw in a slope box. You see I've done 2 here to show you that it doesn't really matter which way you do it. You'll still come up with the same slope of negative 1. Double check that it's going downhill. Yep. I've drawn in my slope box. Rise 3, run 1. 3 divided by 1 is 3. The slope of this line is 3. Double check it's going uphill, so it's positive. Yep, I'm good.